Alright, welcome to my YouTube channel. Remember, I'm still the boiling point. Please, if you've not subscribed to my YouTube channel, do well to do that. Alright, we'll be entering another topic in physics, which is gravitational force or gravitational field. So I have a lot of questions under gravitational force and gravitational field. So let's start with question number one. Question number one, they say Kepler's third law of planetary motion is expressed by dash. Option A, F is directly proportional to m1 m2 over r square. Option B, T square is directly proportional to r cube. Option C, F is inversely proportional to r square. And option D is T square is inversely proportional to r square. How do we solve this? First of all, you need to understand the concept of Kepler. We have what we call Kepler's law of planetary motion. So we have the first law, we have the second law, but what they are trying to ask us from this question is the third law of Kepler's. And the third law of Kepler's law states that the square of the period of planetary motion is directly proportional to the cube of the separating distance. Let me repeat. The square of the period of the planetary motion is directly proportional to the cube of the separating distance. How did they get this? Or how did he describe this? For him to be able to describe this, he put up two theories. And that theory is the theory of centripetal force. The theory of centripetal force and the theory of gravitational force. The theory of gravitational force. What he's trying to say is that, remember that the planet moves around the sun. If the planet is moving around the sun, there is a force that is holding that planet in that circular path. That force that is holding the planet in that circular path is called centripetal force. So according to Kepler, Kepler says that this centripetal force, which is the force that is holding the planet in the circular path, is provided by a force called gravitational force. That means centripetal force is provided by a force called what? Gravitational force. Question: what is centripetal force and what is gravitational force? Centripetal force, you know that centripetal force, according to the formula, is mv squared over r. This is the formula for centripetal force. While gravitational force is g m over r squared. So this is the formula for gravitational force, while this is the formula for centripetal force. So according to Kepler, centripetal force is equal to gravitational force. Remember, this m will cancel one m here, right? One r will cancel one r here. So what is remaining? I'll have it as v squared is now equal to what? Gm over r. Can you still remember this? V squared is equal to Gm over r. Now recall, since the body is moving in a circular motion, recall that V is equal to omega r. If you can recall that V is equal to omega r, then also recall that T, omega, is equal to 2 pi over T. Therefore, V is equal to, any place I see omega, what is omega? 2 pi over T. I will have it as 2 pi over T times what? R. You get? But what we are having here, we are having V square. If we are having the V square, that means I will take the square of this. If I take the square of this, I will now have that V square will now be equal to 4 pi square r square over T square. So my V square is 4 pi square r square over T square. So any place I see V square, what am I going to put? I will now have it as 4 pi square r square over T square is now equal to G m all over r. You will cross multiply. If you cross multiply, what are you going to be having? You have it as 4 pi square r cube because this r squared times r will be r cubed is now equal to t squared gm. Can you make t squared the subject of the formula? Yes. You divide all through by gm, divide all through by gm. So I will now have this will cancel this, right? I will now have that t squared will now be equal to 4 pi square over gm, then you have r cubed. Now this 4 pi square over gm is a constant, therefore I'll have it as t square is equals to k r cubed, which is something as t square is directly proportional to r cubed. You get it now? So that is how they got this formula, that the square of the period of the planetary motion of the planet is directly proportional to the separating distance apart. So the correct answer to question number 1 is option B. Please note it. Option B. Now, question number 2. Question number 2. Question number 2. Question number 2. They asked, they said, what weight would be experienced by a man of mass 200 grams who stand on a lift if the lift is ascending with an acceleration of 0.25 meter per second square? Take G is equals to 10 meter per second square. Option A, I have it as 2.05 Newton. Option B, 2.0 Newton. Option C, 0.5 Newton. Option D, 0.205 Newton. How do you describe this? First of all, I want us to bring out our data first, then I will now describe. So you write data. When you write data, the first thing that they gave us, they said a man of mass 200 grams. So they gave us the mass. The mass is 200 grams. And you know that in physics, the unit of mass is not in gram. It is in what? In kg, right? So how do you convert gram to kg? I will now have it as 200 divided by 1000. So 200 divided by 1000, what are you going to have? I will have it as 0.2 kg. So divided by 1000. That means if you want to convert gram to kilogram, you divide by 1000. But if you want to convert kilogram to gram, you times by 1000. But remember, in physics, the SI unit for mass is kilogram. That is the first one. Then they said who stand on the lift if the lift is ascending with an acceleration of, so they gave us acceleration, which is A. What is the acceleration? Acceleration is 0.25 meter per second square. Then they say take G, that means they gave us G. What is G? 10 meter per second square. So how do you describe this? So the first thing I want you to note is, now look up. You have a lift, and this is the lift. Inside this lift, I have a man that is standing inside the lift, and this is a rope that is pulling this lift up, because they said that the lift, if the lift is ascending, that means the lift is moving up. If the lift is moving up, there is a force that is pushing the lift up. That force that is pushing the lift up is called tension. You get? So if the lift is moving up, is ascending, that means there is a force that's actually pushing the lift up, and that force is called what? Tension. Now remember that this man is standing inside the lift. So, and the man will possess a weight, and the weight of this man will be moving downward. So I have two forces that are acting here. Number one is that I have a force that is pushing the lift up, and I have a force that is acting downward, which is the weight. But guess what? The lift, is it moving up or is it moving down? The lift is actually moving up. If the lift is moving up, it means that the tension force, which is the force that is pulling the lift up, is greater than the weight of this man. Of course, if the weight of this man is greater than the tension, it will be moving down. Are you getting me now? So if the tension force is greater than the weight of the lift, then what will I have? For me to make this thing equal, tension and weight to be equal, that means I will add another force here. That means tension force, if it is equal to the weight, I will add something here, and that thing that I'm going to add is called force. So I'll have that the tension force is equals to weight plus force. And you know weight, what is weight? Weight is mg, which is mass times acceleration due to what? Gravity. I will have it as mass times acceleration due to gravity plus what is force? Ma. So force is ma. So what is common? You discover that m is common. I will have that tension is now equal to m in bracket g plus a. So I'll have that tension. Did they give us mass? Yes. What is the mass? 0.2 in bracket. Did they give us acceleration due to gravity? Yes. What is it? 10. Plus, did they give us acceleration? Yes. What is it? 0.25. So 10 plus 0.25, 10 plus 0.25, you have it as 10.25 times it by 0.2 times 0.2. I will have that the tension is equals to 2.05 Newton. Do we have anything like 2.05 Newton in the option? Okay, option A is 2.05 Newton. So the correct answer is option A. Please note it. Question number 3. Question number 3. They said a satellite weighs 80 Newton at the Earth's surface. If the radius of the Earth, if R is the Earth radius, at what distance from the Earth would the weight of the satellite be 20 Newton? Wow, let's see how we can be able to analyze this question. Let's see how we can be able to solve this. Okay, now look up. Let me repeat the question. They said a satellite weighs 80 Newton. So what is the weight of the satellite? Initial weight of the satellite. So weight of the satellite is 80 Newton. At the Earth's surface, if R is the radius of the Earth, that means when the satellite was weighing 80 Newton, what is the radius of the Earth? R. The radius of the Earth was R. Then I say, at what distance from the Earth would the weight of the satellite be 20 Newton? That means if I choose the next distance, let me call it R. Are you getting me? So at what this distance we are looking for this, right? That the weight of the satellite will be 20 Newton. So what do we apply? Remember that this weight is a force, right? Can I call this one my F1? This force, that means my F1, which is the first weight, is 80 Newton, right? While my R is R, then my F2 is 20 Newton, and the second R is what we don't know. So remember, you apply what we call inverse square law. Inverse square law under gravitational force of attraction, which states that the gravitational force of attraction is inversely proportional to the square of the distance apart. It is called inverse square law. If it's directly proportional, that means for me to remove the sign of proportionality, I will introduce constant. So I will introduce constant. I will have that F is equals to K all over R square. Now, since we have F1, I will have that F1 will now be equal to K all over, what is the radius in F1? I have it as big radius, right? Then F2 will now be K all over what will be the radius? Root 2, which is actually what we are looking for. So F1 divided by F2. What is F1 divided by F2? I'll have the F1 divided by F2. What is F1? K over rho square, divided by K over rho square. So I will now have that F1 over F2 will now be equals to K over rho square. Yes, rho square times, once multiplication is introduced, inversion will take place, which is rho square over K. So what is going to cancel? K will cancel K, right? Therefore, I will now have that F1 over F2 will now be equal to rho square over rho square. You get? So did they give us F1? What is the force of F1? 80 Newton. I have it as 80 over, did they give us F2? F2 is 20, is equal to, what am I going to have here? Rho square all over rho square, right? 80 divided by 4. 80 divided by 20. 80 divided by 20, that should be 4. 80 divided by 20 is 4. So I have here to be 4 is equal to, since here is square, can I take it all square? I'll have it as R over R all square, right? So how do I eliminate this square? Take the square root of both sides. So take this square root and take this square root. This square will cancel this square root. I will now have, what's the square root of 4? 2 is equals to R over R. We are looking for this small r, make it the subject of the formula. You now have that r will now be 2r. So the distance when the force is 20 Newton is 2 times the original r. So do we have anything like 2 times the original r in the option? Option A is r over 4, option B is r over 2, option C is r, option D is 2r. So the correct answer is 2r, option D. Now question number 4 they said the planet describe ellipse about the sun as one focus is dash. Write your branch. B. Kepler. C. Gravitational. D. Isaac Newton. Please, the correct answer is Kepler's. This is the first law of Kepler's. Remember I told you that Kepler's described 3 laws. First law, second law, and third law. So according to the first law of Kepler's, he said that the planet describe ellipse about the sun as one focus. What are they trying to talk about? Now Kepler was trying to tell us that the planet, the orbit is not circular. The orbit is elliptical. We call it a stretched circle. So, and there are 2 focal points. So this is the first focal point, this is the second focal point. At one focal point, that is where the sun is located. So the sun is located. And remember that the planet, this one is the planet. The planet orbits around the sun. So this sun is not located at the center. The sun is located at one focus or one foci. If the sun is located at one foci, you discover that there are times in which the planet will be closer to the sun, and there are times in which the planet will be far from the sun. So that is what the first law of Kepler is trying to tell us. Unlike our belief that the planet, the orbit is circular and the sun is at the center, and the earth or the planet revolves around the sun at the center. No, it doesn't. So the person that gave us a clear picture of how the planet moves around the sun is called Kepler, which is option B. So note it. So we'll go to question number 5 for now.